Russia boasts the largest network of operating inland waterways, more than 100,000 kilometers. Water transport provides a host of significant benefits, from the relatively low prime cost of transportation, the ability to transport large size and heavy freight, to high energy efficiency, safety and ecological sustainability. The combined integration of Russian inland waterways with the European water transport ring is one of the most important strategic challenges in developing the Russian transport system. In order for the waterway to connect European Union states, Russia and Asia, the task of re-engineering Russian inland waterways has to be solved, which is grandiose in its sheer scope and scale of capital investment. This includes the complex development of the Volga-Don shipping canal. The Volga-Don waterway comprises the Volga-Don shipping canal, 101 kilometers in length, 13 locks, the Tsimlyansk reservoir, 187 kilometers in length, with locks of the Tsimlyansk hydro system, and the lock section of the lower Don with its 3 hydro systems. The most complex section of this waterway is the Volga-Don shipping canal. The canal is divided into 3 sections according to the nature and elevation of the terrain: the Volga slope, watershed, and the Don slope. The Volga slope rises 88 meters to the watershed and is overcome by 9 locks. Then, by cutting through the deep channel of the watershed, the canal joins the Varvarovka reservoir and descends 44 meters to the Don, to the Bereslavka and Karpovka reservoirs, and 4 locks. The canal is fed with water from the Tsimlyansk reservoir by the use of 3 cascade pump stations. Each has an output of 45 cubic meters per second. The pump stations supply water to the summit reach to a height of 44 meters for shipping and irrigation. Annually, they pump more than 1 billion cubic meters of water. The locks of the Volga-Don were built more than 60 years ago and designed for shipping with a freight carrying capacity up to 3,000 tons. The detailed design provides for the following shipping dimensions: a guaranteed transit navigation depth in the canal and a lock sill depth of 365 centimeters and an effective chamber length of 145 meters and width of 18 meters. Currently, up to 80% of freight is transported in Volga-Don type freight motor vessels and tankers with freight carrying capacity up to 6,000 tons, requiring a guaranteed navigable channel depth of 400 centimeters. The specific weight of such vessels keeps on rising, thus creating greater stress on the canal's hydraulic structures more and more. As the guaranteed depths are no more than 365 centimeters, vessels are not fully loaded and incur losses of approximately 2 million tons in freight annually. However, the main problem of the Volga-Don waterway is that it only has 1 navigable channel. There is remarkable similarity between the Volga-Don and a typical busy highway. The waterways of the Volga-Don basin are some of the most overstretched shipping waterways. 40 vessels pass through the locks every day. The canal's design carrying capacity of 10.5 million tons per year has virtually been exceeded. Moreover, there is a non-uniform 5-to-1 ratio, respectively, in the direction of freight flows, Volga to Don and Don to Volga. Vessels queuing to pass through the locks build up during the busiest shipping seasons, and the waiting time for locking is on the increase. It is very difficult to ensure shipping safety and stability in a single-lane lock system. In the event of a standstill, due to technical or emergency reasons, shipping may come to a complete halt in both directions along a whole stretch of waterway. There is an obvious need to build a second Volga-Don channel. Volga-Don 2 is one of the largest and most important plans according to the document Strategy for Developing Russian Inland Water Transport by 2030. Creating a second channel of the Volga-Don shipping canal directly parallel with the existing channel is not possible at present. This is due to an existing Volgograd site development. Moreover, the Tsemlyansk reservoir, which is already suffering from a water shortage, cannot provide the required volumes to supply the canal. Preliminary design solutions have been drawn to date which take into account the degree of site development, natural and climatic factors, geological, hydrological, water resource management, ecological, and other influencing factors. A new bypass shipping canal has been proposed, 41 kilometers, 800 meters in length, with access to the Volga River and not far from Tatyanka, 37 kilometers downstream of the existing canal, circumventing the Krasnoarmeyski district of Volgograd. The new canal is planned to be joined to the existing one downstream of lock number 9 in the summit reach. 4 single-lane locks, each with a height of 22 meters, are to be built in this section. The inland waterway will then run along the existing canal route with additionally built second channels at locks 10, 11, 12 and 13 and into the Tsemlyansk reservoir. Then the waterway will pass in the direction of the Don River with channels built at locks 14 and 15, Nikolaevsk and Konstantinovsk hydro systems, and through the twin-channel new Bagaevsky hydro system. The built locks will have chambers 300 meters in length, 30 meters in width, and a minimum sill depth of 5.5 meters for simultaneous locking of 2 design vessels with a load carrying capacity of 5,000 tons. Plans are also being made to build a Power South canal with 4 pump stations, each pumping 250 cubic meters per second, the first option, or a Power North canal with a system of pump stations, each pumping 50 cubic meters per second, the second option, whereby the shipping canal route will be broadened from 38 meters to 60 meters. The freight transit capacity of the new locks and the new channels of existing locks in 2 directions will consequently reach 19.5 million tons. The total carrying capacity of the canal following re-engineering operations will be upwards of 35.5 million tons, with an average shipping period of 227 days. Building of the Volga-Don 2 will increase the carrying capacity of the Russian integrated deepwater system, produce favorable conditions for shifting freight flow over from terrestrial forms of transport to water transport, thus reducing the high utilized capacity of terrestrial highways in the south of Russia and improving the environment. Volga-Don 2 will help Russia enlarge its activity in international transport corridors. Developing inland water transport will have a considerable socio-economic effect, stimulate the business investment climate, and create thousands of workplaces. New prospects will unfold for state and private investors alike, not only in projects relating to the construction of Volga-Don 2, but associated with the modernization of infrastructure, building of modern roads, bridges, crossings, container terminals, transshipment points, and the manufacture of new rolling stock. Volga-Don 2 will be a significant milestone in the development of freight and passenger shipping companies. New Volga-Don opportunities will bring a boost to cruise shipping, an influx of tourists to Russia from all over the world, and affect all related sectors. Improving the quality and accessibility of water transport on intercity and commuter lines will be an extra incentive to boost domestic tourism. Building the second Volga-Don channel corresponds to demands for an innovative course of growth for the Russian economy and corresponds to global worldwide trends.